All right, guys, good to be here. Actually, this is probably the first presentation in Amsterdam that I've done probably since 2019 or something like that, so it's been quite a while. Quick introduction of myself. So firstly, I just want to say, actually, that color there, that really weird green, it's supposed to be that blue over there. So just whenever you see green, just think blue. So I am the CEO and one of the co-founders of a company called Intent Architect. I have an engineering background. I've been coding since I was a teenager. Did a couple of years as a software architect at a consultancy, and then a few years as a CTO before I went full-time into this business back in 2018. And just at a high level, what I want to cover today is I want to introduce you guys to, you guys saw the title of the presentation, Architectural Automation and Pattern Reuse in dotnet. So I'd like to just cover an introduction at a very high level, conceptually, to pattern reuse. And then I think to really just give you guys an idea of what this actually is in the real world, I'm going to show you a live demo. And then we're going to save a little bit of time at the end just to ask some questions. I think what is important, though, is that getting through this conceptual aspects of pattern reuse is very, very important so that we understand what we're looking at when we actually get to the demo. All right, so to kick it off, I think a good place to start is with the familiar. As software developers, and I assume I am talking to a room full of software developers. Is everyone here a software developer? Yes? Okay, cool, yeah. Thanks, Eric. I almost got a bit nervous there. So, yeah, wrong audience. So these are the challenges that we tend to face, right? We've got the pressure to deliver, the business is always on our case, standardization, code-based inconsistency. We've got to basically add governance, make sure that the team's acting as a single unit. There's always the tendency towards legacy, technology is getting outdated, and you can read through all of these things. These are just typical problems that we face as developers. The thing is that before I get into a little bit about how we can optimize these things, how we can mitigate these things, how we can actually find more time to spend on some of these problems, there are a few insights that I want to share with you guys. But before I do that, I just want to check, do any of these resonate with you guys? Okay, can I just get a show of hands? Okay. Like 2 people in the room, all right. All right, so the first insight that I want to share with you guys is this. Between 35 and 85% of code-based related tasks are predictable and repetitive, okay? They're predictable in the sense that we know, there's you could say a formula to them, and they're repetitive in the sense that we tend to be doing them over and over as we progress. And while I think once a lot of developers understand what we're talking about in this predictable and repetitive space, many of them will say to us, this is something that they've actually known intuitively. We've known this the whole time. It is something that we don't really have the tools to deal with. Okay, we kind of just have to deal with the slog. So just to understand this a bit better, I want to give you guys some examples. So let's just see. The first place that we can see this predictable and repetitive aspect to building software is in the code base itself. So a very simple example, every time you need to build a RESTful service in ASP.NET Core, I'm going to keep it .NET, obviously, because you guys are all .NET. We're going to have a lot of controllers. Okay, you guys are probably very familiar with the controller classes. And if we take a look at our system, every single controller class in the entire system is unique. Okay, they all have different routing, they have different contracts, the dispatch and all that kind of stuff. It's very, very different per controller, but at the same time, they're all the same. Okay, at least in a good system, they'll all have some element of the same. And it's really the sameness that we can call the controller pattern, because the dispatch tends to be the same. Maybe it's interface dispatch, or you're dispatching onto a mediator pattern or something like that. But ultimately, it is something that we can see is the same across all of our controllers. Another example, very simply, is the entities. Okay, entities in the system, every single one of them is unique. We've got the address, we've got the employee, we've got the client, whatever the different names are. But every single one of them in a typical system has a set of standards. Okay, we're going to be using, basic properties or backing field properties. We're going to have either it's DDD, there's going to be operations. There is a formula to essentially back this, and we can call that the entities pattern. Okay, and when we take a look at this and we break it down into a criteria, essentially what we're going to realize is that these patterns essentially follow a set of implementation rules. This is what makes them predictable, okay? And they are required for every service domain in this example, or for whatever part of the system we want to build. So they are repetitive. And so we can say in this very broad sense, and I know you guys are all probably very familiar with design patterns and integration patterns and architecture patterns and things like that. The definition of pattern for this presentation today is that a pattern is anything code-based related that is predictable and repetitive. If we just zoom out a little bit and we take a look at a very typical architecture, there's our controllers, there's our entities. But these patterns are everywhere, okay? There are, this is a CQRS API, so you've got commands and queries, you've got DTOs, validators, the handlers for the commands and queries, maybe there's a little bit of domain eventing, ORM mappings, dependency injection, everything that I've mentioned there and that's on the screen right now, and so many more things in the system are essentially just patterns. These are predictable and repetitive aspects of the systems that we build, particularly in the architecture side of the system. Then, just to give you a bit more context around this, that's just really focusing on the architecture. So the architecture is the one on the left here. I think that's the same for you guys. It's the one on the left. You can see that there's a very high, just so you know, by the way, this data that I'm putting is based on research that we did across 22 different companies involving north of 100 developers. And so these are actually averages that we've pulled out that I'm sharing with you guys today. On the architecture side of things, we see very, very high predictable, repetitive aspects to the architecture, okay? And that's very, very clear, and I think when I show you guys the demo, you're gonna just see how clear that really is. Business logic, on the other hand, not so predictable and repetitive. Now, that's not a surprise, right? Because business logic is usually unique to the application that we're trying to build. It's not something that you're gonna see in another application. But at the same time, there is some level of predictable and repetitive there. Easy example is CRUD, okay? CRUD is very predictable and repetitive. Mappings, also very predictable and repetitive. Governance, why is governance very high? Well, it's just mainly because most of the policing work that seniors have to do, that you guys probably have to do, it's around the architecture. You're just making sure that the juniors crossed all the T's and dotted all the I's and that there's no mistakes and that the standardized aspects of the system we follow, the architecture's being followed. And so governance actually has a large amount of predictable and repetitive work that goes into that too. Automated tests, of course, because a lot of them test the architecture. And you've got the user interface. I mean, there's some very clear ones there, like the proxies and the DTOs and stuff like that. But of course, CRUD front ends, there's always an element of CRUD to most systems. Some systems are a lot of CRUD, other systems are much, much less. And so these numbers will vary depending on your project. So these aren't the de facto numbers. Your project has different ratios of all of these. And these are just averages that we've seen across the projects that we've analyzed in the space. And from what we can tell, it's pretty much what it's pretty much there for the most part. When we average this out, we're looking at about 54% of projects basically being predictable and repetitive on average. We've seen projects that are so predictable and repetitive that, we'll get into that a little bit later, but you also get ones that are very, very low on that. So these very, very highly specialized, customized applications that really don't resemble line of business applications and things like that. All right, so this may sound quite depressing, by the way. I'm sure that, 56% is predictable, repetitive. It probably doesn't sound to be a very happy thought, but there is some light at the end of the tunnel. The one last thing I wanted to just touch on here is we have to kind of quantify this in terms of our time. So to do that, we have to take in not just the time that we spend on our code base, we have to take in the time that we also spend doing everything else as developers. So there is all the admin work, there's the meetings, the planning, collaborations, all that kind of thing that we have to do. But when we break it down on this, and this is really also just around averages, we do know that some studies, for example, estimate that 50% of time in certain companies, you'll be spending 50% of your time not on the code base. If that's your case, I'm really sorry about that. I've never worked on a team that has such a big overhead, but there are some studies that do suggest that can be the case. But in a nutshell, what we're looking at here is we're looking at around just under 4 months of the work on average of our entire year that goes into this predictable, repetitive landscape. So in all of this, okay, as depressing as it is, there is an opportunity, okay? And this opportunity is really there because predictable and repetitive tasks yield a massive opportunity for automation, okay? So I don't know if that scares anybody, because sometimes people get scared by the idea of automation, knocking out their jobs or something ridiculous. We definitely do not see that happening. In fact, the only thing that we really see here is that this level of automation is something that is going to just separate companies. It's just going to separate the guys who are moving very slowly from those that are moving at a much, much different pace, okay? All right, so I want to jump into now what we can do about this. Okay, so we've kind of alluded to the fact that there's automation in the background. I want to introduce you to pattern reuse. So at a very high level, we like to think of pattern reuse as the missing tool in the developer's toolbox. So where the industry has essentially given us a set of tools already, we've got code reuse. That's all the NuGet packages, the frameworks, the seed works, any kind of abstraction that you may get up to in order to not have to reinvent the wheel. There's that. Okay. There's the architectures, which handle all our non-functional requirements, ensure that there's good separation of concerns, make sure that we can actually build out systems that can last, okay, that can actually grow and be flexible. So there's that. And there's also the methodologies, the agile, the TDD, DDD, and all those kind of different methodologies to building out the systems. But where we find and where we reach these limits, and I don't know if you guys are how clear it is where those limits are, but just as an example, in code reuse, you can reuse as much code as you want, but you still check out your code base and you find yourself staring at 100,000 lines of code. Okay, so it can only go so far. You can only reuse so many libraries before you end up just coding out the in-betweens. Okay. And so it's really where we reach these limitations that pattern reuse is the next tool that we can take out of our toolbox and we can apply it into the software development space and we can have a huge impact. So what is pattern reuse in a nutshell? Okay, we've spoken about patterns. If you think about all those patterns, those controllers and DTOs, commands, queries, all those kind of things that we've seen throughout our system, from the top all the way through to the bottom, pattern reuse is really the process of taking these patterns, capturing them as artifacts, okay, and then rolling them out in an automated fashion into our code base. Okay, that's really the high-level flow. But in order for this to really make sense, okay, and for it to actually work, you also need an additional component. This is the models and metadata. You need something to drive what the artifacts will ultimately yield or manifest as in terms of individual actual files in a code base that is actually going to work. Okay, so this is very, very high-level and conceptual, and this is something that we're going to focus on when I get to the demo side of things. But what is important is obviously understanding why would we even do this in the first place, and that's because pattern reuse has a massive amount of benefits. The first thing is the efficiencies and the time savings. So we looked at that. We're spending 4 months. If we can just even knock off 50% of that, that's massive. Okay, that means that there's a lot of other time to spend working on all those other things that we mentioned. We can go fix up a lot of technical debt, focus on maybe getting some other features out, all those kind of things. So saving a lot of time is great. Okay, it means that we as developers could go spend time doing other things, or we can just work with the business to get more features out. This also brings in this idea of a free architecture. Okay, and that's really because if you're taking a look at all those patterns that make up the architecture, we essentially can turn those into artifacts and automate that into our system, which actually yields a free architecture. We've got standardization, consistency, and architectural adherence. Okay, this is really where you see a huge quality boost to the applications, because keeping applications consistent is pretty much what all the governance is for. That's where most of the pull requests come in. That's where most of the policing work comes. And it's something which is very, very important because entropy and kind of this progressive deterioration of code bases is ultimately what leads us to the dreaded legacy system. It's ultimately a combination of, inconsistency throughout the system, entropy everywhere, stuck on old technologies. No one wants to touch it. You know that this thing's going to take me 3 days, but on a new system, this is going to take me 20 minutes. That's really the legacy system. So the standardization, consistency, and that architectural adherence is massively important. Of course, we're assuming here that the correct architecture was chosen. Codebase upgradability, this isn't an obvious one, but it's something where, and it's linked to, you could say, the legacy aspects of getting stuck on old technologies. The patterns that you have, okay, with time, those patterns are probably going to change. So you may be using, you may have built your system on .NET Framework. At some point, you're going to get up to .NET Core, but there could be breaking API changes in the technologies that you chose. And when you run into that, you can't necessarily make that change without rewriting almost that entire section, that entire layer of the code base. You probably have to rewrite it. But with pattern reuse, you can pretty much automate that upgrade. Okay, you can literally just swap from this, this pattern to that pattern and move on. The last thing here, and this is really just connecting back to that models and metadata that was coming in. This is the self-documenting of the models. Okay, so this essentially is those models. If you had to visualize those models, what you should be looking at is the blueprint of your system. You should be looking at some kind of a self-documentation of this is the blueprint of the design of my system at a very high level. And if this seems very, very conceptual at this point, it is very conceptual at this point. I'm going to connect the dots and actually turn this into a real-world example shortly. So that's basically the perfect segue to throw up that slide. So just a full disclaimer. So I mentioned that I'm the CEO of this company called Intent Architect. This is our product. It's a commercial product. We've basically this product's been in production, well, it's in development and production for the last 7 years. So it's been around for quite a while. And I just want to be upfront about that. I'm a shareholder in that company too. But this is the best way that I can show you guys this in action. All right. So what is Intent Architect? I just want to run you through a quick introduction. Okay, it's a platform for pattern reuse, first and foremost. Okay, so for developers to achieve pattern reuse, that is what it is fundamentally. Another way we like to describe it is as a next generation code automation platform. So the reason that we call it next generation is because under the hood of Intent Architect, there's essentially a set of quite sophisticated mechanisms that we employ to be able to bring code automation into the software development space in a very, you could say, powerful and comprehensive way. But I think the most important thing there is that it's in a practical way. Because we all build software in the real world, the devil's in the details. We know that there's always going to be something that's going to break out of the mold. You can't mold software. Otherwise, you could say that the low-code guys would have won the battle by now. So that's why we call it next generation. It's part of these kind of advanced language support capabilities. The tool itself, just to be clear in case there's any confusion, is for the developers and the architects. It's for the very technical people. Okay, so we work with very technical teams of guys building in high-code languages. So specifically C#, Java, Kotlin, TypeScript. Those are the languages that we currently support. The last thing that I think is also just worth mentioning here is that the tool is very configurable, extensible, and that's really because you guys all know that every software project is different, right? Every architecture is maybe the same but slightly different technologies, different standards, all that kind of stuff. You have to be able to adapt to the real world that you're operating in. It also just helps to understand what it's not. So you guys are familiar with the low-code platforms, I assume. So you're familiar with the OutSystems and the Mendix and the Salesforces. So we don't really see low-code as a good way to build competitive applications. So if you're building a piece of software that you're going to take to market to go and thump the competition, you're going to struggle to do that in a low-code system. But we're 100% high-code orientated, and we just see low-code as a very disempowering way to build software, both for the organizations as well as for the developers, for many, many reasons. That said, we do acknowledge that there is a place for low-code in the industry. The second thing is we're not a scaffolding tool. So if you guys are familiar with JHipster, and there's lots of scaffolding tools out there, so kind of templatized scaffolding systems and things like that. We're not a scaffolding tool. We like to distance ourselves quite a lot from there. From the scaffolding tools, they are very rudimentary, very, very rudimentary in what they do. And it's quite different in a sense, the mechanisms that we employ in order to achieve what we do. So I just wanted to make that clear as well. We're not a framework, okay? That means that we don't introduce any runtime dependencies into anyone's environment. So that's obviously very good because that means that there's no lock-in to a tool like Intent Architect. And the last thing that I just wanted to mention here is that we're non-prescriptive. So this is quite interesting because what that means is we don't prescribe the architecture, the technologies, we don't prescribe the standards, the SDLC, how the team likes to work, what the team likes to do. We're essentially able to plug Intent Architect in through this configurable and extensible systems and the way that it works. We're able to plug it into the environments that we ultimately operate in. This is really just some marketing, blah, blah, blah. The only thing that I think is worth mentioning here is that there's self-documenting design. So there's very powerful designing systems in Intent Architect. I'm going to show you guys some of this in the demo. And the other thing that I think is just worth mentioning is that there's this additional level of control that pattern reuse in particular, and Intent Architect obviously being a platform for that is able to achieve it, gives developers, and that is it gives an additional level of control over the code base, over and above what the IDE gives us. Okay, so in case it's not clear at this point, Intent Architect or a tool like this doesn't replace the IDE. We're still operating in a high code environment, so we're still operating in C# and TypeScript or whatever languages we're using. But this additional level of control allows us to make large-scale changes to the system. So in an IDE, you can control RR if that's a shortcut for you, and you can rename something, a method, and if it's used in 20 places, it'll go update those 20 places, and that could update 10 files in your system. So that is useful, but it's not a large-scale change. If you want to make a large-scale change, like for example, upgrading from, let's just say there's breaking changes between EF6 now and EF7, okay, you may need to make some changes to your system. Upgrading that in one go, in the same sense of like a rename, that's essentially what the equivalent is in the pattern reuse space. Okay, we can make these large-scale upgrades, stay on top of the latest technologies, avoid our systems becoming legacy systems, and we can also do things like introduce cost-cutting concerns, bolting on additional technologies, shifting patterns. I mean, we all know that you begin with a certain set of patterns on a project, especially if you're new in the technology space. You begin with a couple of patterns, and then you realize a better way to do things. Now, how great would it be to just retroactively go and apply all those patterns back to the rest of the system that's already been built? So that's just the last bit on that. The last thing that I think that I want to touch on, and this is quite important before we go into the demo, is how do we achieve pattern reuse? Okay, like how do we actually do this? Now, what mechanisms does Intent Architect use to achieve this? And there's essentially 3 mechanisms, but the first thing I can say about it is that it's really hard to do, okay? To do it effectively, it's really, really hard to do. It's something that we've essentially spent the last, 7 years or so, perfecting. And in a nutshell, we've got 3 mechanisms that we use to achieve pattern reuse. So the first mechanism is what we call modules. Now, each of these things is really what we're going to focus on in the demo, because this is really about showing you guys how pattern reuse works. So modules are the artifacts of pattern reuse. So if you recall earlier, we take those patterns, we turn them into artifacts. Those get rolled out in an automated way into our code base, okay? These are the artifacts of pattern reuse. They're essentially the plugins, okay? So it's how we compose. They also support things like architectural, like compositional architectures, where you compose it of what you need just for this project, okay? It's also one of the ways that we can accommodate all the different architectures, because it's just which patterns are we using in this architecture. We use those ones. If not, we install different ones, okay? So that's the first mechanism, very, very key. The second is the code management. And I'm going to be taking you guys through these and show you lots of examples as we go through this. So the second is code management. So code management, if I was to really simplify it, it's a way of telling the tool, Intent Architect, which lines of code or which parts of the code base are under the management of Intent Architect and which parts of the code base are under the management of the developer, okay, at a very, very granular level of control. So we need to be able to tell the tool that, because ultimately, and we need to be able to shift those rules around, because we need to be able to sidestep the architecture sometimes, okay? Like sometimes you need to break out of what the standard architecture practice is. You need to be able to handle the real world. There's always an exception. Like software may be 99% the same, and then 1% an exception, and that 1% of an exception, if you're stuck in some kind of an automation system, will just stuff you up. So it's really, really important. This is a very key piece of that practicality. The last thing that the last piece of the puzzle here, if you want to think of it like that, is the visual modeling system. So I've mentioned the visual modeling systems. We've got very, very powerful visual modeling systems in Intent Architect, and they're configurable and extensible, but that's not something that we're going to get into in terms of this demo today, but I'll try and give you an idea of how that fits together. But we will be showing you some of the modeling systems that we have, that I have got prepared for the demo. But what it allows guys to do, and we've had lots of companies do things like this, is, for example, just create their own modeling systems. So essentially DSLs for things like workflows or for infrastructure as code systems and testing and things like that. So that's the last piece of the puzzle, and that's essentially what drives the modules in terms of what code's supposed to come out the other side. So I think without further ado, let's get into the demo. All right, so I'm going to launch up Intent Architect. I hope that this is coming through all right on the screen over here. It looks beautiful over there. Okay, so just to orientate you, the first thing that you'll notice here is that the tool's installed on my local machine. So I'm running Windows. Common question we get is, do we support Mac and Linux? And the answer is yes. This is, I think, version 3.3 point something. So this is actually I'm quite excited to be showing you guys this particular version, because the tool's really come a long way over the last years. I think we released 3.3 end of May or something like that. We released 3.2 end of last year, 3.1 mid last year, version 3 end of the year before that, version 2 end of the year before that. So it's been quite a while, and so there's a lot of, you could say, accumulated experience has really come through a lot of people that we've worked with and helped in the space. So just to orientate you very quickly at a high level here, we've got some links to our documentation. So we've got a lot of documentation on how to use the tool. Then just below that, I've got, these are solutions that I've personally opened on my machine recently. The only thing that I can really say about this is that we dog food Intent Architect. So we use it to build itself, okay? And that's been quite valuable for us. We've been able to build very, very quickly, very, very quickly, in fact. And we use it to automate both the architecture of our server as well as the architecture of this particular application, which, as you can imagine, are quite different. But then just in terms of using the tool today, so I'm a dev for all intensive purposes of this demo. And that's really where we're going to focus today. And I'm going to create an application. But you can see there's another starting point here called create a new module. So just to remind you, modules are the artifacts of pattern reuse. And we've got an entire ecosystem around building modules. So this is essentially the systems where we can go and codify up these different patterns. And I'm going to be showing you guys examples of modules that our team has built. And all of those modules are, in fact, open source. All right, so I'm going to kick off creating a new application just so you guys can see this. I'm just going to run through this quite quickly. These are the application templates. You know, each of our clients tends to have their own ones. What I'm going to follow today, are you guys familiar with the, does that, oh, sure, okay. Maybe I can switch this into dark mode. It'll be better. Oh, well, you guys can't see, right? Can you see that? Is that better? All right, fantastic. Okay, well, this is my preferred approach as well. Okay, so are you guys familiar with Uncle Bob's clean architecture? Just want to get a show of hands. Who's familiar with Uncle Bob? Okay, great. Yeah, so this is a very standard clean architecture. I'm a huge fan. I mean, most of the good architectures tended to have this kind of structure in any case. And so we've got a application template which has got those patterns pre-set up. So I'm glad some of you guys have seen this because this will all be very familiar then. So let's create a demo app today, and maybe we'll just call this, what's it? .NET Meetup, okay, as a solution name. I think one thing that is just worth mentioning here, as you can see, there's this little checkbox here to store the files separately to the code base. This is kind of important because what that's alluding to is two things. One, all the files for the models that we create are stored locally, which means that they essentially would get checked in to the repository that we would check our code base in, but just in a separate folder. So we've got essentially the metadata and the models for our system alongside the code base. That means that there's no like kind of third-party information leaving and some kind of a security risk from that perspective. But that is quite important also because, of course, if you're working on version 2 of an application and you were to switch to version 1, you want to be able to, you guys can read that all right, or is it just very difficult? Yeah. It's a bit blurred. Okay. I will read stuff in case you guys can't read it. Yeah, but you can switch between your different versions in your repository, in your Git repository, and you will be able to see the models that are for that particular version. Okay, so I'm going to say next. So this is where we start essentially looking at modules, artifacts of pattern reuse. Okay, that's essentially what these are. So we're looking at ASP.NET Core RESTful API. So we're looking at things like in here we'll see the controllers, the startup, the program, that kind of stuff. We've got JWT authentication. We've got Swashbuckle for our open API. We've got mediator pattern, that's the Jimmy Bogart library. Order mapper, also the Jimmy Bogart library for mapping our domain entities over to DTOs. Fluent validation, very popular framework for doing validations. And obviously it all links very nicely into the mediator pattern. I think the only thing that's really worth just kind of talking about a little bit more here is this is additional CRUD support, okay? What this is, it's a module. So we talked a little earlier about business logic having a certain predictable and repetitive aspect. So this module here, and I know you guys maybe, I don't know how easy it is for you guys to read that, but that just says additional CRUD support. And that's essentially a module which helps us automate CRUD because CRUD itself is predictable and repetitive, so we can automate it. Entities, a lot of guys think that entities is business logic. It's not, okay? Domain eventing, that's a very useful pattern if you guys are familiar with it. Entity framework core, of course, we could use a Dapper, we could use whatever, but this particular architecture has been set up for EF. And we've got a repository pattern to abstract that away from our business logic, which I'm a fan of doing. Serilog for logging. We can bring in multi-tenancy if we wanted to in this particular application template. And then we've got Visual Studio integration. That's really CS proj files, SLN files. They're predictable. They're repetitive. You can automate them. Okay. So I'm just going to say create. And what it's going to do now is it's going to download and install all of those modules. So those blocks that we could tick, and I could have unticked some of those, just so that's clear. I can pick just what I need for this particular application. It's now going to just, that list of modules that I selected there is going to install all of those modules and their dependencies, okay? And you can see that there's version numbers and things like that. So it's a very similar paradigm. If you're familiar with code reuse and NuGet packages, it's the same paradigm. You've got a version, this is the identifier, that's its version number, this is the dependencies, and you can version your modules and essentially your patterns. And that's really where we're talking about that upgradability. Different versions can upgrade your system and affect it quite differently. All right, so just orientate you very quickly now. If we go back to the home, here's our .NET Meetup solution. If we were in a microservice architecture, we would see, well, here's our demo app, and we would see all of our different microservices listed underneath this. If we come into demo app, this is essentially a set of settings that we can look at. And all of these settings are actually coming in through the modules. So modules in the intent architect world are a little bit more than just pattern reuse. They can do pattern reuse, but they're also just the plugins, okay? You can plug in all kinds of things, including designers, settings, things like that. This is really where we talk to developers about this idea of creating a developer experience. So how do you want your developers to experience working with this tool? And that's really something that developers decide on for themselves. Okay, so in terms of modules, you guys are probably very familiar with this paradigm. We've had a lot of Java guys say that they really like it. But this is the browse, installed, update, just missing the consolidate option over there. The idea here is that you can browse for modules. I've got a couple of repositories here. So you can see I've got a couple of, these are client modules, okay? But if I just switched over to our server, these are the open source modules that Intent has created, or at least our team has created. And we can see also what's installed. And if there are any updates, we could go fetch those updates, for example. But very similar to a NuGet environment, there could be thousands of NuGet packages out there, but you install just 20 of them. It's only those 20 that matter in your runtime. Similarly, in the pattern reuse space, it's only the 20 modules that you install that are the 20 patterns that are going to work in this particular environment for this particular app. So that's how different apps in the same, you could have just different microservices running completely different architectures. One using a Redis cache, the other one using a MongoDB, the other one using different, just databases as an example. And of course, if there are any updates, we could pull those updates. I'm a little scared of these updates because they're very new and I would have to just double check on my team. So I'm just going to leave those alone. Okay, so then the last things that I want to just touch on is I just want to check that you guys in a minute are just happy with everything and that there's no confusion so far, is we've got these designers, okay? We've got a Visual Studio Designer, services, and domain. Now these list of designers, I can, for example, add another one. So let's say we were in a microservice architecture. We could install eventing, okay? And if we install eventing, you can see I get a new designer over here. I'm going to show you guys these designers in a second, but this is really just to showcase that we can have whatever designers we need for the particular app that we're building, okay? So if you're building an app that's a very vanilla, web service, you're probably going to have services and you're probably going to have some kind of persistence, so a domain of some sort. Maybe if you're in microservices, you probably have eventing. If you're doing workflows, you may actually create your own one, okay? All right, and then the other thing that I just wanted to mention here is this is the Visual Studio Designer. This setup is essentially setting out the structure for the application. So these are different CS proj files essentially, okay? So this is the Web API one. I wonder if there's a way that I can, no, it doesn't let me. I thought maybe I could zoom in a little bit just so I could show you guys a bit better. The interesting thing about this is that this is setting it up. What set this out in the first place was the application template. We can obviously go rename these things. We can go add new projects and things like that. But essentially, this is a structure that comes with the application template, but it's also a targeting system. So this is how we target or tell this tool where the code must go in the code base. It's also how we plug in to existing. Okay, so Visual Studio is a targeting system as well. This allows us to tell the tool where the code must go in the code base. It also allows us to plug into existing code bases because we just need to replicate the structures of that code base. We're going to get into these designers shortly, so like the domain and the services in a second. But essentially right now there's no code base. Okay, so just wanted to make that clear. Really just don't want to lose you guys at any point here. If I click this, it's going to say this location does not exist. If there was an application there or something in that folder, it would open up. But right now, there's no application. So I just want to make that clear. Those were not NuGet packages that we saw downloading earlier. Those were modules. The NuGet packages, artifact of code reuse, modules, artifact of pattern reuse. When we want to create the code base, we need to essentially kick off that automation sequence. Okay, and this is the software factory execution. And what it does is it runs through all the modules that we've actually installed. And at this point, because we haven't designed our application, it's essentially doing a basic scaffold. So nothing too fancy over here. But what it is doing is it's just staging everything for us. All of this is just staged. I'm not sure if that makes sense, but what it means is that this is just in memory. Okay? If I wanted to take a look at any of these things, I can also do that too. But the philosophy here is, and I can see that this is just basically the app.json. Maybe one that's probably a little bit more familiar is like the startup. This follows a kind of more older startup approach, okay? This one hasn't been brought up to the, the lean version of things. So this is, the philosophy here is essentially that the tool should never touch the code base without your direct consent, okay? So you don't want to get surprised by something over here. If we're not happy with this, we can shut it down, we can kick it off again, and it's going to offer us exactly the same changes. If we're happy with these changes, we can say apply, and we've got a code base now. So I can kick this off. While this is opening, I just want to check, is everyone following up to this point? There's nothing that I've said that's confusing anybody. It's all pretty straightforward, right? Okay, great. Okay, so we're getting up our .NET code base, and now we're probably in a little bit of familiar territory. While that's happening, the first place I want to start is, let's just start with the designers, okay? So the domain designer, I'm a DDD guy. I really enjoy building systems in DDD, but that's not a prerequisite. It's just that that's where I would typically start. Most guys, if they're not DDD, they would start in the database. I don't see a huge difference, but I'm going to start in the domain nonetheless. And let's say the business comes to me and says, Gareth, I need you to build us a system to manage users, to manage privileges, to be able to assign these privileges to the users. Very basic security domain, right? Now that's such a simple security domain, I can just do that in my head. Okay, it's just so straightforward. But if the business came to me and said, Gareth, we need you to build a bulk task management system to handle all the different bulk tasks in a system, in a kind of pause, start, stop fashion, and needs to be able to handle all the ones into the future, that's a much more complicated system. Okay, as I'm sure you guys can imagine. I know that because I built one a couple of years back. And the way that we went about doing that is we went to the whiteboard, I went with my top designers, my top engineers, and we started fleshing this out. We started drawing boxes. We said, well, this is what we're going to persist. These are the services we're going to expose. These are the events we're going to publish. These are the ones we're going to subscribe to. These are the front ends that we're going to stick out there. All these different things. We started putting this all on the whiteboard. And what we can do is we can actually capture all of that in a modeling system. Okay, so coming back to our very simple example, I can start by creating my user. And I'm just going to use some shortcuts here just to speed ourselves through this. I can create my user. I can create this idea of a privilege. Let's just drag that over there. I can also just come here and create our, it's very zoomed in, create our assigned privilege. So we'll actually assigned privilege. And what I'm doing over here, just so it's very clear, is I've got the model. The model is the truth. I've got a view on that model. I can have as many views as I want. Okay, so if I create another diagram, I can go switch to this view, and there's my user over here. If I switch back to that view, it's that structure over there. So the views are separate. They're just a view onto your truth, okay, the truth of your design. We can also obviously fill this in and say, well, our users are, have many, so is collection true, have many privileges, and each privilege is linked to a user. So this is a one-to-many relationship. Doesn't that look a hell of a lot like UML? You guys are familiar with UML, right? It looks a lot like UML. Why? Because this designer has been configured to feel like UML. Because UML is just like so concise. It's beautiful. Okay, like you can infer pretty much your entire database structure in a relational database with UML. Same for a doc store. It's all very, very straightforward. So UML is great. Class diagram, at least, that's what I'm referring to. Class diagram in UML. But we're not restricted here by some OMG standard where you have to only work within these certain boundaries. We obviously can break out of that if we need to be able to handle the real world scenario that we're trying to deal with in the software space. So I'm just going to fill this all in as well, just get some stuff out here. So let's say we need a name and a surname and an email address and maybe, I don't know, a date of birth, which is, I'll just make it a date time. And let's just say it is active, which is a Boolean. Let's say that I wanted to add a name over here. I'm just using shortcuts, guys, description. And maybe over here, let's just make this a meaningful table. We'll have like a can view, which is a Boolean, and maybe a can update, which is also a Boolean. Okay. If we were in DDD, I'm not sure if anyone here is in a DDD kind of environment, we can add an operation. Let's just say it'll be called assign. Let's just give ourselves a bit of space here so we can see what we're doing. Assign privilege, and I don't want to actually create a separate operation. I want to create a parameter called the actual privilege, and I'll pass the privilege in. Okay, just so we've got an operation, we can go play with it later. If I push save, now one thing I did earlier is I minimized the software factory execution. So that's what's sitting at the bottom over here. So you'll notice every time I push save, it re-kicks it off. It's running in the background, and then when it's ready, it's going to start flashing and essentially annoying me and saying, there are 21 files that need to be created as part of this particular design. So if we go through this, we can see here that some files have changed, some files are new. We can obviously go take a look at them. So what happened to the DB context? Maybe I can zoom out a little bit over here. Can you guys still see that? Is that okay? Or is it still too tight? Maybe just one in. Is that better? Okay. So, I mean, these are just the DB sets, right? I wouldn't worry too much about it. I just want to make sure you guys can see kind of what the code is. If it's just a blur, it's just useless. So let me know if it's just a blur, and I'll zoom in a little bit more. But this is just registering those up, okay? That's the only change that we're seeing over there. Of course, the user configuration. Did I double click that? There we go. So of course the user configuration, here you can see this is actually bringing in some other aspects of our architecture, the domain events. But there's our relationships. This is all linked in because, of course, the relationship that we set up was a compositional relationship. That means that the life cycles are connected, and we can immediately transfer that to the database. Okay, so here is a cascading delete. We've got configurations, we've got repositories, we've got interfaces. Of course, these are as part of a clean architecture, so the interfaces will be in the domain layer. We've got our entities. This is a bit of an extravagant pattern. I wouldn't worry too much about this. A lot of guys have different entity patterns. This pattern essentially separates the entity itself and it basically uses an interface. So if we took a look at our user state over here, we've got the user implementing iUser, and so when our repositories return things, they won't return the user, they'll return the iUser. So just in case that was a little bit confusing. If we're happy with all of this, we can apply it, and we've essentially got, get some brightness going here, we've essentially got a full-fledged persistence layer ready to go in the structure that we set out with our entities. We're actually using quite a cool VS feature over here. We can obviously edit the VS files, so we just essentially embed these things. This was an idea, by the way, that we got from the functional guys, where we essentially separate the business logic from the state, okay, which is it's more of a functional kind of idea. So here we've just got the business logic. We're using a partial class for that, not because of an intent architect aspect, but mainly just for nice separation there. You guys may notice these though, okay, intent managed, mode merge, default intent managed, signature fully, these kind of things. I'm going to circle back to this shortly. This is actually code management instructions, okay, that we can, I'll run you guys through that in a bit of detail shortly. So coming back to this now, let's say that the business was quite happy and they said to me, cool, Gareth, this is great, but we need you to, this is not really working for us because users need to have addresses on them. I can come here and I can obviously just go and create my address. I can add my, line 1 and line 2 and my city and my postal code or something like that. And I can go and set up the relationships. And we can say that this may have an address, but each address is 100% belonging to that user. So 1201 relationship, we can push save, and intent is going to now shift the code base to this structure, okay? So our user state is going to now have the address. Now you guys may look at this and say, I would never in my life use a backing property that looks like this. That's totally fine, because of course, whatever module one uses, that's the whole idea. It's your pattern. Whatever pattern is working in your environment, that's just a module. This is a module which does it this way. There were reasons that this module was done this way. We've got a dependency injection update over here, so it's adding in an additional repository for us. A lot of guys would prefer that to just happen on aggregate roots only. There's our additional address. There's our registering up the configuration. And you can see all the little pieces that need to happen throughout the code base. They're all part of a pattern, okay? They all just link together. If I apply this, the code's basically there. If I realize that was a bad idea, I can just delete that, and we can reverse our way out of that design, okay? So what is important about this is that even though we are, shifting this code base around, I mean, I'm not doing massive shifts right now. What very often happens when we build software is we build out with a certain design. We then start getting to the business logic. When we get to the business logic, we realize that the design that we set out actually doesn't quite cut it. And it's usually at this point that we have a choice. Either we have to rebuild, across many layers, all of that work, or we're going to hack the system. And it all usually depends where in the sprint I am and how big that hack is going to be versus how much work it's going to be. And so we can avoid a lot of that if most of the architecture, because the architecture is something you can see here, if a computer can do it, just let the computer do it, okay? This is pretty much standard EF with repository patterns. We could put specification patterns and things in here. But if a computer is involved, let the computer just do that aspect, and we can find out right away whether this business logic is going to cut it. If it's not, we can just shift the design. So that's just a little bit about the domain modeling. The one other thing I just wanted to show you guys here is, of course, this isn't going to, there's nothing so far that we've really specified around the database. And we can actually go and use a feature in the tool for the modeling sides of things that allows us to capture additional metadata. And this is something you always need to do. You need to capture additional information on whatever element you're dealing with. So in this case, I'm looking at an attribute. If I wanted to, I could say apply stereotype. And this is this extension system. And I've got a list of stereotypes here. Where do these come from? These are not built into intent, the same way the domain is not built into intent. This actually comes from a module that we built called intent metadata RDBMS, which is, if we hop over here, RDBMS DB. Yeah, there we go. That's what's installed here. That's where they come from. So they're very easy to set up, and we can just go and say, well, this one's coming in with very generic RDMMS concepts. So we've got an index over there, maybe we want to chuck an index over here too. You can see this, there's a stereotype, that's where they get added at the bottom of here, just very zoomed in at the moment, so it's a little bit tight. But we can also see that we've got these text constraints. And of course, we can go and set all of these. We can say, well, let's go set these all to 100 or something like that. For these, we'll set these all to 1,000. So these are just metadata extensions. Now, of course, it's only useful if it's true in the underlying code base. Otherwise, if we had to come take a look at this model and we had to understand this model, we would not be, if we can't trust that there's truth to what we're looking at in the code base, this model is fundamentally deceiving, which is the problem with most UML models that we create in order to capture the designs of our system. So if we come in now, we run the software factory execution, you're going to see all these little changes are coming in now. So it's going to apply those. Max length is 100. It's going to apply the index over there. Very, very straightforward stuff here, but just to give you guys an idea. Once we're happy with that, we can apply it, and that's just a little bit around the domain. Just to close the loop on this, of course, services are part of this. Now, if I wanted to create a new service, I could say, well, let's just create a users folder so I can separate things out. Let's create a command called create user command. And I want to actually use one of the features of intent is a mapping system. I can say, well, I just want to map it to pretty much what the command is, maybe excluding the is active. And we can just go map that command up. We can go and create ourselves a service, which will ultimately, in this particular case, we can turn that service into a RESTful controller, or we can turn it into a gRPC service, or whatever we need to turn it into. In this case, it'll become a RESTful controller because of the module we installed. We've got our users. Let's call it a user service. And I can go here and I can add an operation for this command. And essentially, it's just going to name it, create user. Let's just call it just create, okay, with spelled correctly. And if I save that now, it's going to set this up. This is very, very kind of manual, and it's a little bit cruddy as well. So what you'll see here is, of course, there's our controller. Okay. As I mentioned earlier in the beginning, when we were talking about the conceptual sides of things, controllers just tend to look the same, but each one of them is different. This one's called create. What it accepts in is a create user command. That's all unique. The dispatch is pretty much standard across all controllers. What it returns, well, based on a set of rules, based on our understanding, we're going to return a 2 or 1 in this particular case. We can also set up all the response types because it's all predictable. It's all predictable. It's all repetitive. It's essentially part of the pattern. Okay. If we take a look at our command, okay, the command is just a very straightforward pattern, okay, just basically setting it up. But of course, you can make sure that you cross all the T's and dot all the I's, so this will absolutely have an I command on it. We've got our handler. Now, this gets a little bit interesting because what you can see here is that it actually auto-implemented this, okay, and it did it in an anemic way. So if you're a DDD guy, you'd be like, no, this is terrible. But if you're just used to doing things in an anemic way, which most guys do, and it's perfectly fine, this is an anemic implementation. Add it to the repository, move on. The architecture that's been set up for here, it's in terms of this particular version of the clean architecture, it uses the mediator pipeline to manage the transactionality and the saves. Okay, so we don't actually need to worry about that. We don't want to really be too concerned about our transactionality when we save, when we escalate locks in the database, those kind of things. You don't want to be concerned about that stuff in your business logic. So that's always a sign of a good architecture is good separation of concerns. You don't want to have two concerns in here. So we're just adding it to the repository pattern and moving on. Now, one thing that you can see here is that this is set out to say intent fully managed, also the body's fully, okay, which is a bit redundant, which is basically saying you can go, intent, you're in control here. So I'm going to circle back to this shortly. But if, for example, I uninstall a module here. Let's just go find that CRUD module that I was talking about earlier. And let's go and uninstall that. The software factory is immediately going to kick off again. So I can actually just head straight back to this class, wait for it to update. So it's updated over here. And we can see that now it's changing its tune. It's actually switching over to a, I don't know what you want to do, but you're on your own, developer. And you can see that the body is set to ignore. So if you're familiar with, I think this is pretty interesting for you guys. We use, to understand code files throughout the code base in every aspect for the C# stuff, we use Roslyn. So if you guys are familiar with Roslyn, we use Roslyn to literally understand the full code base that intent architect is aware of, okay? And you can see here that we've got a body in the Roslyn world, well, in pretty much all languages. The body is considered everything from, and I'm just scrolling around because I'm so zoomed in, is pretty much everything between those two handle braces, okay? And it says your implementation here, body is ignored, which means that the developer can just go wild in here and just build out whatever they need to do. Coming back though, if I went to my, let's just go reinstall this CRUD thing, you'll see that it'll just go and basically turn this back and auto-implement it again for us. There we go. Every time by the way, it happens automatically because the software factory just kicks off immediately. It's minimized, kicks off immediately, and then just stages the output for us. If we come into the services now, this is obviously the slow way, okay? I can do this. I can say, just give me CRUD services actually, just for the user. Now the reason that this exists is because, so one thing that's important to understand here is that the way that this tool has been built is not for CRUD, okay? This tool's been built for the most complex use case. So it's been built for all the weirdest contracts and stuff like that you could want to do. But because it's built for that, doing CRUD is just really, really straightforward and simple, okay? And so what we can do is we can set up scripting systems to essentially automate the CRUD aspects. And so this is something that's not built into intent. It's also just plugged in through that actual, this option here that you guys are seeing, this create CRUD service, that comes in from that CRUD module, okay? And the reason that this is interesting is because what we're looking at here is we're looking at automating something that's predictable and repetitive about our design. So we've already established that we can automate the predictable and repetitive aspects around our code base, but there's also the element of our design. Sometimes our design itself is actually quite predictable and repetitive too. So if we're building a CRUD system, you could just automate that. But of course, no system is 100% CRUD, okay? And so you need to be able to diverge. And so because you're here, you can diverge. You can say, well, for example, I'm not going to pass in the is active. You can, for example, say on the user DTO, I'm going to include all the address information, which is not just generic CRUD. So if you were trying to use a CRUD framework, you would fall over. And no one's really created, I mean, ABP is probably the most mature CRUD framework out there, and it's also just, rife with lots of issues and stuff. So you want to be able to diverge very, very easily. So that's just something around that. The one thing that I can just quickly show you on this is if I uninstall this CRUD module and we come back to the services, you're going to see that this option doesn't exist. Okay. And if we install it back, this option will exist now. There's the CRUD service. So the last thing I want to cover in just the last few minutes here is I want to show you guys, well, this is great because we haven't done any coding. Okay. To give you an idea, most developers spend maybe 10% of their time, at most, designing. Designing is very, very quick, okay? Usually you're just like, this is my general design, I think this is pretty good. Obviously, the more complicated the use case is, the more time you're going to spend designing, the more time you're going to spend collaborating. Then the rest of the time you're going to spend in your code base, okay? And that's where we want to be spending our time. We want to be solving real problems, okay? Not problems that essentially computers can solve. So I want to go take a look at those services that we saw earlier. In fact, did I even apply them? Let's just apply them quickly. There we go. And there they all are, users. So if we take a look at this create, I want to just chat to you guys a little bit around this code management side of things. So what the code management is doing is it's telling Intent Architect on every single execution, it's telling the tool, look, if you want to understand how this file should be managed, you just look at these tags, and these tags are going to tell us what's going on. So we can see that there's a few tags. In this particular file, there's more tags than usual. Why? Because here we're at a very fine-grained level of control. We're in essentially a place where business logic goes. And so in places where there's a lot of business logic, we tend to set the granularity very, very fine. And what we're saying here is that the signature is allowed to be managed, but the body is ignored, okay? Merge means that you can add, Intent can add, it can update, but it mustn't delete. Okay, that's what merge means. So these are little instructions. I don't want to get too deep into it, but at a very, very high level, it's quite intuitive. So let's just play around with this. Let's say I wanted to actually put my own business logic in here. So if I had a request, and let's just say my date of birth was less than, I don't know, date time. Let's just say, I don't know, can you... Yeah, okay, cool. Yeah, let's just guaranteed, exactly. If you weren't born, all right, so basically we're going to just throw an exception over here. I mean, the point really is that we can just get, some business logic that I wrote as a developer, some gibberish to the console. I hope no one's got OCD in the room. So we've got this business logic here. We re-execute the software factory execution. And what do we get? We get a change. It says, no, what are you doing? You can't do that, okay? And this is where it all falls apart, right? You're just like, God damn, I need to be able to write my business logic. But this is where we can just set these controls. I can say, actually, ignore that. And as soon as I push save, it recalculates, and it shows us, actually, I'm going to keep this code for you now. So on the right here is what intent wants to do. On the left here is what the source code is. Funny?
What about the other parts that you didn't touch? Will that stay intact? Or?
Yes. Well, you can see exactly what it's going to do on the outside. So let's take them one step further. So let's say I put here an ignore. Okay. So it's going to ignore that. If I, for example, said, well, what if I have a private void do something? You know, we're going to do something. And I'm going to console.writeLine, you know, some other gibberish to the console. Now, if I push save, it's going to keep that. Now, why is it going to keep that? It's also going to fix my formatting there. Why is it going to keep that? Well, that's because of this instruction. This instruction says merge, add, update, but don't remove, because that's the default. So whenever we set up a pattern, you're going to say, well, actually, I want the developer to just go and add their stuff in here. I don't want this thing to come in and, you know, blow my foot off. But the developer can just come in here and add whatever they want in this particular class space. But if I were to change this instruction for this particular file and I said fully and I push save, it's going to say, well, actually, no, this doesn't exist. It's going to delete because I've told it you're allowed to add, you're allowed to update, and you can delete. But if I actually am now, even if that was the case, I can still come in here and I can say intent, manage this, ignore. And I can push save, and it's going to keep it. Okay, and it's going to fix my formatting again. And it's still going to fix my white space. Okay, we're winning. So we have the control here to be able to essentially set out the rules for any particular file at any level of granularity in the system. And if I was to, I just want to give you guys one more example, and then we can switch over to questions. If we needed to, for example, go into another aspect of the code base, damn, this is bright. And I was taking, I should have switched this to dark mode too. Can you guys read that all right? Oh, it's awesome. Should we just try the dark mode here too, just quickly? Theme. Is it going to be a problem? Eric?
I was wondering, I don't think Visual Studio is clever enough to...
I think it is.
Yeah, this is way better.
Yeah, I think it. Is that better? All right, cool. Note to self, don't listen to Eric when he says go to light mode. So let's say, for example, taking a look at the save changes over here. So this is obviously overriding the save changes. Why? Because we want to do a dispatch of the events. This is the Jimmy Bogart style of event dispatching. There's essentially 3 different patterns. This is one of the nicest. This is the most testable one. There are other ones with other pros and cons, but this is, you just link it in with any infrastructure. In this case, we've linked it in with our save changes. So save changes kicks off, and we've got the dispatched events. But what happens if I came in here and I said, I need to do some interception here without the G here. Okay. So I wanted to put some logic in there. I need to call something. I need to be able to do that. If we re-execute the software factory execution, it's going to say, no. That's the old pattern. The old pattern had, need to do some interception here. The new one doesn't have that. But this is where we can come in again. And I showed you guys this briefly, but I'm just showing you more in the infrastructure level. I can just step out of this, and I can say mode, ignore, and it's going to leave me alone. But if I'm in here and I came and I said, what about here? And I push save, it's going to stay. Why? Because this is a fully managed method. But if I take this ignore and I put it over there and I say save, now we're good. If I take it off and I take it away, it's going to delete it. I can also just say, well, you know what, this whole class is mine. And I just push save, there we go, whole class is mine, it's going to leave me alone. I can also say, well, the whole file's mine too. And then it's just like, no, we're not going to get touched at all. Okay. So what is important get in your way. Okay, it's one of the reasons why I think a lot of, you could say, previous attempts, anything even remotely similar to this has just fallen over, because the practicality sides of it, you end up convoluting your code base. You don't want to convolute your code base. There's a few philosophies that we have. The first is, if you go, the first one is, if a computer can do it, just let the computer do it. Okay. The second one is, if you're going to automate stuff, make sure it's the best pattern. Don't go and automate some crazy, rubbish, convoluted something. It should be, your code base should look as if your best developer wrote it on their best day, okay? Like you as the team decide, this is the architecture, these are our standards, this is what we want. Of course, we can evolve that with time, but that must be the way it works. And then the final thing, which is what we're looking at here, is you should never, even if you're using an automation system, you should never have to convolute your code base, okay? You should always be able to get around it. It should never impede your delivery. So I know at any moment in time, if I have a very, very tight schedule, and I need to get something out, and this automation system, the architect who set up my pattern, doesn't quite cut it, or I just don't have time to go fix it up myself, okay? There's some edge case that I wasn't aware of. I can just put an ignore on this, step into the code, change it to what it needs to be, and move on. Come back to it at a later stage. There are other tools that we use for that. I can also just ignore this change for the time being, and then the software factory is just not going to go and touch this file for the time. So this is a nice way. We recommend guys do this just as a reminder so that they're like, okay, I'll get back to this when I've got some time. Right now, I've got a deadline to hit. Guys, that is essentially a very, very high level. There's a hell of a lot more stuff I could show you guys, but we are out of time. Let me stop there and get your questions.
Just quickly one question from that ignore again. Is it ignoring the whole body or only the things you change?
Yeah, that's a good point there. Let's just hop in here. So that was in our, so this instruction is saying fully, which means everything's basically fully, attributes, signature, but the body's ignored. So if I came here and I got a little bit creative and I said Boolean myparam, I just hope that I haven't made any other changes here. No, don't want to open up Slack. Ted's not going to be happy with that. Okay, why? Because you have diverged from the pattern, essentially. Okay, so if you diverge from your models, the tool is essentially going to correct it. Okay, so that is one way that we can be absolutely certain that when we look at this, what we're looking at is the truth. Of course, if the developer wants to, I mean, you can have a legitimate case for this. You can say, well, actually, ignore the whole thing. And well, actually, no, sorry, wrong place. Let's go here. Ignore the whole thing from here. Ignore, save. And then we're going to see that update. This is just using this is just Visual Studio diff tool. You could use any diff tool. I've just got like the output essentially and the source code on the left. So we can control that, but the default is we want to keep this fully managed. Why? Because this is what links in with the overarching architecture. So you want to keep the parts that are linking in with the architecture. You want to keep those automated. But you don't want to keep, the business logic must be for the developer. Does that answer the question?
Yeah, but on the body part of things, so there you infer to only ignore the body.
Yes.
But if I only want to add my bits but keep the generated body.
Oh, yeah, so great question, actually. The thing is that usually where that occurs, okay, because we have had that question many, many times, so we could probably build systems which could do that, okay, but usually what it is indicative of is two concerns in one place. So you're actually muddying the waters of your system, okay, by combining, sometimes guys want to, for example, say begin transaction, end transaction, it's like, and then business logic. That's transactional handling, one concern, business logic, other concern, same place. So what you'd rather do is you'd rather put it into some kind of a pipeline, okay, and you'd rather just dispatch just the business logic by itself. Does that answer the question? Or change the pattern. Exactly, especially if the pattern is, business logic, remember, that's going to fall under the developer. So it's one thing that has to be clear here is that the code that Intent Architect is managing, you can upgrade that instantly. So this system that we've built today, I don't know, it's probably like 3,000 lines of code or so. This system, if we wanted to upgrade it, it's not a very big system, I could do it by hand. But when you've been going at this for 6 months or 6 years, the system's massive. And if you want to upgrade, your 500 different controllers by hand, it's just not possible, and then the businesses are usually facing, that's where, guys do a lot of microservice strangler patterns and things like that to try break the systems out into smaller pieces. But all of that really, I'm a fan, like doing that, would definitely recommend it. But what we do see in that is that after a while, then you just end up with lots of different microservices all running lots of different technologies. So there's a lot of these problems that come in there. Any code that's managed by like a code automation system that's doing essentially effective pattern reuse, you can keep that whole code base under control, and you're just going to focus in on the business logic. That's where we want to go, is just the business logic, and focus on solving problems. Does that answer the question? Great. Guys, does anyone else have any other questions? Yeah.
Yeah, to which extent do you support the unit test? Do you have a module which comes into
We don't have a module I can show you, but we do have examples that other guys have done, but I wouldn't be able to show you now as part of this. But yeah, it's something that, if it's predictable and repetitive, absolutely.
And the secondly, that most of the code is just generated, and you probably don't need a coverage for that. But if you use the body equals mode ignore, then it's your business logic, and you want to cover that. So how can you achieve that with reasonable numbers on the coverage?
So I just don't understand the question. You're asking like, how can I get statistics on how much of the code base is?
The numbers, so because if I get a 20%, the manager says, okay, that's not covered by units, but most of the code of the module is just integrated, right?
Yeah. So you're talking more about like the unit testing aspect, how much code coverage the unit testing has. I'm struggling to hear you a little bit here. What is the question there around that, 20% or 80% of the coverage?
How you can help developers to achieve good, reasonable numbers
Hmm.
and judgment on the code quality.
Yeah, okay. Okay, I think I understand the question. So the question is, can we use pattern reuse to help essentially with the code coverage of the code base? Is that the question?
Yeah, kind of. Let's say, for instance, if you can generate a separate partial classes for the implementation which are marked with body ignore,
Mm-hmm.
and keep all the generated code in the generated subfolders
Mm-hmm. Mm-hmm.
where we don't care about the coverage.
Oh, yeah, okay, I hear you. So, look, I would box that into what I call convolution. So you're convoluting your code base. Okay, so you're doing something that if you got rid of the automation system, you wouldn't be a happy camper with your code base. So that's why we wouldn't want to do that. But to come back to the code coverage, and I'll try to answer it like this and just check if I'm on the right track, is we can automate the tests that cover all of that code that's already automated. Okay, so we can get, by default, if we installed a module which automated the tests for the domain, for the persistence, all of the integration tests probably, the unit tests around all the infrastructural components, the controllers, all that kind of stuff, we would probably be at a massive amount of code coverage. The only thing that we wouldn't be able to cover is the business logic, because that's the developer. But we could generate, very similar to what we did here, we could generate at least some parts of where those tests must be done. So we can already generate failing tests for developers if we need to too. Does that answer? Am I on the right track here?
Yeah, yes. So and that can be achieved only by the custom-made, the more custom-made functions. So not available in the system right now, but
So all modules are essentially just plugins. Yeah, so it would just be a module that one would set up. Setting up a module, like it's not a big deal. If it sounds like it's a big deal, we set up like entire architectures in about 4 days with one developer. So there's an entire ecosystem for it. It's very, very easy to do. So if we, for example, wanted to set up a testing module that followed a certain pattern, it wouldn't be such a huge ordeal to do that. But the principle would be the same. For pattern reuse, you could, if you wanted to, you could, absolutely. Does that answer the question? Okay, cool. Anyone else? Does anyone else have? Yeah.
Go ahead. Sorry. Is it possible to create custom models or edit the one that are already built?
Yes. So creating custom modules, if we just come back to the home here, I can create a new module pretty quickly. I mean, I'd be able to spin one up for you guys in a few minutes here, but we could just say a C# module and create it, and I can get down to essentially, this may be a little bit confusing just by the way, because I'm using intent to automate the creation of modules. So it's in a different world now, okay, a little bit of inception going on here. The reason that we do this is because modules are predictable and repetitive for the most part. So all the infrastructure that holds a module together, predictable and repetitive, so we can just automate that, and then it just gets down to, well, what does my module need to do? And we just go implement that. So yeah, so creating modules is, I would say, so we work with all kinds of companies, dev houses, SMBs, the insurance companies and the banks and stuff. And most of them manage and build their own modules. The good news is that it's all done in C#, which is something that the Java guys don't love, but you guys, it wouldn't be a shock to you guys. Yeah? Do you have a question?
I was wondering, do you have modules for authentication?
Yes, yeah, we did. Yeah, we've got some modules here that we set up. Just so it makes sense, like most of our clients have their own modules. Most clients have their own modules, but we've set out an identity server. This still uses, by the way, it doesn't use the doend one. The doend one is an upgrade, so this is just really there. It uses the identity server in dotnet 6. It runs, it works. So one could essentially just set that up. You can see it's just slightly, kind of a very, very basic, just bring in the UI. Do we want a UI? Do we not? The core identity server. EF call for maybe persistence. Do we want it? Do we not? So yeah, absolutely. Guys, one last thing I just wanted to throw up here is we do have, so there's a lot of stuff that we didn't cover as part of this, and I'm wondering what I'm loading up. This is scary. No, that's not what I want. That's the one I want. Is we do have a webinar that we're going to be running that you guys are welcome to register for. We'll be doing a little bit more of a deeper dive into Intent Architect. So you guys are welcome to join that webinar, invite people if you'd like. Obviously we're trying to get as much exposure as we can out here in the Netherlands. Just want to check if there's any last questions. All right, guys, thanks very much.